Hi, this is Tom, and in this video we're going to take a look at what's called base notation. And what it is this. Base notation is if you have some number x, for example, if a number x can be written in, we'll call it base a, or we'll call it base, sure, a works, base a, then x equals a raised to some exponent. We'll call it n. So that at first may seem a little strange, but let's try a couple examples, and I think this will make more sense. So for example, write base 8, or write 8 in base 2. So the question is if I have the number 8 and I want base 2, is there some exponent that I can write here so that 2 raised to the exponent is 8? So the question is what goes in there? And you're probably comfortable with 3 as the answer. If I write this with a 3, then 2 raised to the third power is 8. So now we have written 8 in base 2. Now let's try another one. This one's kind of clever. How about write 1/8 in base 2? Well, this one doesn't seem so obvious to me. So I'm going to start out. With my 8, and I'm going to use what I just learned. I know that 8 is 2 cubed. But I can also think of this as 1, because I can also write this as 1/2 cubed. That's also 1/8. Wait, we're almost there. We can flip the base by using negative exponents. So if I flip the base, I get 2 over 1 raised to the negative third power, and 2 over 1 is most simply written as 2 raised to the negative 3. Okay, let's try this. How about one more? Write 8 raised to the 5th power in base 2. Well, there's a couple approaches. I'm going to try what I think is the most simple. If you were to put 8 raised to the 5th power into your calculator, you're going to get a rather large number. For example, I'll actually check. So I'm using my calculator here. And if I did that, I would get 32,768. I'd like to say I did that in my head, but I did use the calculator. But look at this. Let's not even go there. So avoid. Too big. And here's why. What do we already know? This is one of the key things in mathematics, is that if you learn to remember what you've already done, it makes each step progressively cleaner. Because look at what we just did. Right up here, oh, I don't like the red highlighter unless I have to. We found already that 8 is the same as 2 cubed. So let's utilize what we've done. This is instead 2 cubed raised to the 5th power. And we know the rules of exponents dictate that if you have an exponent raised to an exponent, that's the same as multiplication. So this is also 2 to the 3 times 5, or 2 raised to the 15th power. And that's how you can write 8 raised to the 5th power in base 2. And one more point is this. When you're working on these, usually your goal is that your goal is for a whole number base, like 2 or 3 or 4. So a whole number, goal is for a whole number base. Actually, I should say a counting number base. So and usually you're going to be looking at 2, 3, 4, 5, and on up. And you're not going to use 0 because 0 to anything is 1, and you can't use 1 because 1 to anything is 1. But 2, 3, 4, 5, and on, those are all good choices. And for example, if I give you a problem like this, right? 8 in base 3, well, we're going to learn that it can be done, but it's going to be a really ugly exponent. And so because 3 to the first is 3, and 3 squared is 9, 3 misses 8 entirely. So normally when you choose a base, it's one that gives you a nice clean base. So this is kind of a silly problem. It would only make, it's a silly problem. And the reason why, a silly problem, because it makes a more difficult problem more difficult rather than simple result. And that's how we work with numbers written in a certain base. Hope that helps. Thanks for watching.